Oh, remind me to show you the picture of the tree that fell in my house. And I took pictures of my dog, too. I thought you want to see that. What? Oh, yeah. Amen. Let's go. First degree. Polynomials, first degree. First degree is just a line, right? And you're totally used to that. If it's x to the second degree, what shape does that make?
Parabola.
A parabola. Now, don't draw this one. I'll say it again because half the people did it third hour. Don't draw this next one. You're used to seeing a third degree look like that. And a third degree does look like that, but it's rather boring. We're going to look at third degrees that are much more interesting than that. They actually have a little bit more shape to it, something like that. Anybody see a pattern here developing? Anybody guess what's going to happen in the fourth degree?
That's my initial. I'm proud of you.
It kind of keeps on adding another turn, doesn't it? Every time you change a degree, there's another turn that happens. In fact, as you look at this, we call these areas extrema. So, for example, we just got done with a unit where we used word problems to be able to maximize and minimize things. So did we ever find that spot on a graph? We would call that the minimum, right? Did we ever find that spot on the graph? We would call that a maximum. So these have all sorts of maximums and minimums floating around, which is kind of neat. How many maximums or minimums does this one have? None. How about this one? How does that compare to the degree? Very good. So our first thought is this. Given a polynomial of degree n, then there are at most n minus 1 extrema. So what that means is it doesn't have to have that many. We looked at the cubic right away, and that one didn't have any extrema. Didn't have a maximum or a minimum. So at most, it would have n minus 1. Okay, the degree minus 1. And that can help us predict the shapes of the graphs. We want to be able to come up with sketches of these graphs, and by the end of this class, you're going to be able to come up with this sketch like that. You're going to be able to figure out this equation in seconds. Looks like a complicated equation, right? Oh, we're going to be able to come up with that, no problem, because you're extremely smart. So what I want you to do is this. I want you to start to notice patterns. This is really going to help us as we get to Monday. Look at all of these functions. These are all positive functions, okay? What happens as x goes to the right? So as x goes towards positive values, what happens to the y values for all these? All of these finish going what direction? Up. Everybody agreed? Because if you take an even function, say x to the fourth, and you plug in a positive number, is that going to be positive or negative? And if you plug in x to the fifth, positive or negative? Yeah, positives are going to turn out positive. So as you can see, as you plug in positive values, you're going to get out positive results. So what this means is if we have a polynomial where the degree is odd, but it's positive, it finishes positive. As x goes towards positive infinity, the y value goes towards positive infinity. Meaning it finishes going up. That's for the odd ones. Do the even ones finish going up as well? Yeah. So if n is even, if it's an even degree polynomial, then it finishes up as well, which means y goes to infinity. Finishing up means y goes to infinity. That's what it means. All right, let's look at how they start. This one finishes going up, but it starts down. This one finishes up, starts down, finishes up, starts up, finishes up, starts down. What do you notice? What's the... Yeah, the even ones finish up, the odd ones finish down. Why? Or I'm sorry, the odd ones start down. Why? If you plug in a negative number and you raise it to an odd power, is it going to be positive or negative? It's going to be negative. See that? All the odd ones produce negative values then. The even ones don't. So we can see that if n is odd, it will start down and finish up. So starting down means y goes towards negative infinity. And if n is even, then it starts up. Y goes towards positive infinity. Well, what if we don't have a positive polynomial? What if we have a negative one? Okay? That's what the negative one would look like. Or like that. You don't have to draw all these. You can just watch mine. Or if you want to try drawing, you can. It just gets kind of messy at this point, doesn't it? What do you notice about the negative functions? How do they all finish? They all finish going down. Everybody agreed? They all finish going down. So if n is odd and it's negative, then y will finish going down towards negative infinity. And again, if it's a negative function, doesn't matter whether it's odd or even, it will finish down. Y will head towards negative infinity. Now somebody help me draw this pattern. We've talked about it once. Even functions start and end same direction. Everybody agree? Even ones start and end same direction. Odd ones start and end opposite directions. Okay? So, is this talking about an even or an odd? Odd. So if it ends down, then it starts up. Is this last one even or odd? Even. So if it's even, it starts and ends same direction. So if it ends down, it will start down as well. Again, you won't have to memorize that chart. We're going to come up with a process on Monday. It's really going to help you sort through that quickly. So that's a little bit about kind of that end behavior of those functions, but there's something else we want to talk about, and I want you to turn your attention to this guy right over here. If I box this right here, this little area, we're going to try that again, I don't like that. If I box this right there, does that look like an x to the first power, an x to the second power, or an x to the third power? What would you say? Third power. We call that a triple root of a graph. A root is where it crosses the x-axis. We would say that that's an example of a triple root when it makes that shape. So I'm going to go over to triple root here, and I'm going to draw what that shape looks like. Looks just like how we always talked about a cubic looking, okay? Just looks just like that. Anybody want to guess what shape a double root makes? Yeah, so if we look at this one right here, does that look like an x to the first, x to the second, or x to the third? I got the peace sign from Miss Maddie. Thank you. Shout out back there. Peace out. Yep. All right. So I've got a second degree right there because it makes a parabola shape. So a double root looks like a parabola. Does this look like a x to the first, an x to the second, or an x to the third? X to the first, right? And so you notice that it heads through just like x to the first, so that's a single root. And a single root looks like this. So I told you we're going to come up with an equation here, and it's going to be pretty simple, and this is what we'll end with class today. And I'll show you how easy this is. For what value does this cross the x-axis? X equals -2. Everybody agreed? So that means that x plus 2 would be its solution set. If you were plugging -2 to that, you would get 0, right? And we said that it's what root? A first, second, or third? It's a triple root, right? So raised to the third power. And then this is going through what value here? 1. And is it a single root, a double root, or a triple root? A double root. So I'll put a squared on it. This is going through 4. So I'll go x minus 4. And I've got that. And it's a single root, so I'll leave it alone. And then the last one goes through what? So x minus 7 is a single root, double root, or a triple root? Triple root. And if you notice here, you have window, it goes like 40,000, -50,000, goes from -4 to 8. I changed out my window to just try to get a feel. I will press graph here, and you tell me if that's the same graph or not. And how long did it take us to come up with that equation? Not very long at all, did it? So the power of creating shapes and generating graphs with polynomials, it's pretty slick, and we're going to be studying that. So we'll continue on Monday. Great introduction. Good job with your test. Can't wait to see you guys perform the musical tonight.